February 20th, 1943, north of Kasserine Pass, Tunisia. The battle reports would never truly capture what the German tank commanders witnessed that morning. American Sherman tanks executed maneuvers that defied every principle of Wehrmacht doctrine. Through the dust and smoke of the North African battlefield, 5 Sherman tanks, separated by broken terrain and without visual contact, converged on German positions with seemingly impossible timing. No flags, no flares, no dispatch riders. Yet they moved as a single entity, each tank covering blind spots that the others could not see. Every crew knew exactly where their comrades were positioned. In Panzer IVs equipped with FUG-5 radios, German tank commanders struggled to hear their own company leaders through static that overwhelmed their amplitude modulation systems. The 10-watt German transmitters, state-of-the-art in the 1930s, could barely penetrate a few hundred meters while moving. Most German tanks carried only receivers, unable to report what they saw or request support. The Americans operated with technology the Germans didn't even know existed. Frequency modulation radios in every tank, crystal-controlled precision, 25 watts of transmission power, cutting through engine noise and battlefield chaos like a knife through paper. 8,000 meters from Detroit's assembly lines, the most decisive technological advantage of World War II was revealing itself, not in armor thickness or gun caliber, but in invisible electromagnetic waves connecting every American tank crew. This transformation began on July 22, 1941, when the U.S. Army standardized the SCR508, SCR528, and SCR538 radio sets for all medium tanks. While German forces advanced through the Soviet Union relying on command vehicle radio communications, American engineers at the Galvin Manufacturing Company, later Motorola, were perfecting FM technology that would make German systems obsolete. The engineering team included Daniel E. Noble, who envisioned FM technology in military vehicles, and Henryk Mignoski, the principal RF engineer who solved the technical challenges of installing sophisticated electronics in the harsh environment of a tank. Their creation, weighing 181 pounds, transformed every Sherman into a node in the world's first battlefield network. The BC604 transmitter generated 25 watts, 2.5 times the output of the German FUG-5. Operating from 20.0 to 27.9 MHz, it offered 10 preset channels with crystal-controlled stability. The dual BC608 receivers in the STR508 allowed commanders to monitor multiple frequencies simultaneously, a capability that proved decisive in combat. The real revolution lay in frequency modulation itself. Edwin Armstrong's FM technology, licensed to the military, eliminated the static and interference that plagued amplitude modulation systems. While German radios picked up every electrical spark as noise, American FM radios delivered clear voice communications even during artillery barrages. November 8, 1942, Operation Torch brought American armor to North Africa. The 2nd Armored Division's tanks landed near Safi and Fedala with SCR508 radios that would soon demonstrate superiority over German communications. The Afrika Korps, despite being the Wehrmacht's most experienced armored force, faced severe communication limitations. A standard German tank platoon of 5 vehicles included only 1 or 2 with full FUG-5 transceivers capable of both transmitting and receiving. The remaining tanks carried FUG-2 receivers only, able to hear orders but unable to respond or report enemy positions. German platoons relied on rigid hierarchy. When command tanks were destroyed, easily identified by their multiple antennae, the entire platoon lost coordination. This vulnerability proved catastrophic against American forces, where every tank could assume command functions. The Battle of Kasserine Pass, February 14th to 24th, 1943, provided the first major demonstration of American radio superiority. Though tactically a German victory, the battle revealed capabilities that stunned Wehrmacht observers. Scattered elements of the 1st American Armored Division maintained coordination across 50 miles of battlefield. Tank crews who had never met coordinated attacks warned each other of threats and called for artillery support through crystal-clear FM communications. German signals intelligence intercepted American transmissions and noted exceptional clarity and coordination. The 10th Panzer Division's intelligence reported that American units maintained communication at ranges where German radios produced only static. More disturbing was that every American tank appeared capable of full transmission, not just command vehicles. German FUG-5 radios operating on amplitude modulation from 27.0 to 33.3 MHz suffered from fundamental limitations. The 10-watt transmitter struggled to reach 2 to 3 kilometers under ideal conditions, dropping to a few hundred meters while moving. Every spark plug firing, every electrical motor, every track movement generated interference that AM systems could not filter. September 1943 brought American armor to Italy, where mountainous terrain should have negated radio advantages. Instead, FM technology proved even more valuable. The SCR508's frequency modulation handled multipath interference in valleys far better than amplitude modulation. American tanks coordinated movements where visual signals were impossible, and German radios failed completely. American armored units demonstrated capabilities that defied German understanding. Platoons separated by ridgelines coordinated attacks with precision that German doctrine claimed required visual contact. After-action reports described routine coordination at distances where German radios produced only static. June 6, 1944, as Sherman tanks landed at Normandy, their SCR508 radios maintained contact with naval fire support, coordination impossible with German technology. Yet a critical gap emerged. Tank radios could not communicate with infantry radios, operating on incompatible frequencies. The SCR300 infantry radios, 40.0 to 48.0 MHz, could not connect with tank frequencies, 20.0 to 27.9 MHz. This communication gap proved deadly in hedgerows, where German infantry with Panzerfaust could approach American tanks while nearby infantry had no way to warn them. American innovations solved the problem within weeks, mounting EE-8 field telephones on external ammo boxes wired to internal systems. By Operation Cobra in late July 1944, this modification revolutionized tank infantry coordination.
July 25 to 30, 1944, Operation Cobra showcased the full potential of American radio superiority. The 2nd Armored Division under Major General Edward H. Brooks coordinated over 200 Sherman tanks through radio networks, enabling unprecedented battlefield control. German defenders from Panzer Lehr faced an enemy that seemed to possess supernatural awareness. Tanks responded instantly to threats reported miles away, and artillery strikes arrived within minutes of target identification. The contrast with German capabilities was stark. Panzer Lehr, once Germany's premier division, operated mostly without radios, relying on visual signals in terrain with rarely more than 100 meters of visibility. The few functioning radios suffered from interference and limited range. Ironically, Germany had pioneered radio use in armored warfare. Heinz Guderian, architect of Blitzkrieg, had mandated radio equipment in tanks since the 1920s. His 1937 book, Achtung Panzer, emphasized communication as essential to armored operations. Yet by 1943, German production could not meet the radios required by their own doctrine. Out of 5,700 medium tanks produced that year, fewer than 2,000 FUG transceivers were available. Many radios went to command vehicles and assault guns, leaving regular units under-equipped. Soviet forces fared worse. The T-34, despite being the most produced Allied tank, often entered combat without radios, relying on flags and pre-battle planning, with catastrophic results in 1941. By 1943, Lend-Lease provided some relief. American radios, including SCR508 sets, equipped Soviet command tanks, but even by war's end, only about 25% of Soviet tanks carried radios. In comparison, America achieved 100% deployment of sophisticated FM systems. Motorola's Chicago factory exemplified industrial mobilization at its peak. Producing each SCR508 required 2,748 components manufactured to exacting standards. The BC604 transmitter alone contained 474 capacitors and 385 resistors. Crystal oscillators maintain frequency stability despite extreme temperatures and combat vibration. Production numbers tell the story. 1942, 3,800 SCR508 family radios. 1943, 11,400 units. 1944, 24,000 units. Total wartime production exceeded 50,000 radio sets. Every Sherman tank manufactured, 49,324 in total, received a sophisticated radio, an achievement unmatched by any other nation. The SCR508's advantages went beyond frequency modulation. Crystal-controlled stability allowed preset channels to remain aligned under combat conditions. German FUG-5 radios, using variable capacitors, drifted constantly. Dual receivers enabled commanders to monitor platoon and company nets simultaneously. Orders flowed instantly while maintaining awareness of subordinate units. The BC606 intercom integrated with the radio, allowing crews to alert commanders to threats. Noise-canceling headsets and throat microphones enabled clear communication, while many German tanks lacked intercoms entirely. Power management offered another edge. The SCR508 automatically adjusted to 12 or 24 volts. The dynamo motor supplied filtered, stable power, eliminating interference. German radios, powered directly from the vehicle, picked up every spark as static. Universal radio deployment transformed American armored doctrine. Flexible task forces depended entirely on reliable communications. Commanders could create ad hoc battle groups from multiple units, confident they could coordinate through comparable radios. This baffled German commanders accustomed to rigid structures enforced by limited communications. September 1944, Battle of Arcourt. The 4th Armored Division faced multiple German Panzer brigades with Panther tanks, superior in armor and firepower. Yet American radio coordination proved decisive. Every Sherman reported enemy positions instantly. Tank destroyers received targeting info from tanks out of sight. Artillery observers in Sherman command tanks called in devastating barrages within minutes. Over 3 weeks, the 4th Armored destroyed 281 German armored vehicles while losing only 41 Shermans, a 7-to-1 ratio defying technical specifications. Throughout the war, German intelligence failed to grasp the significance of American communications. Reports noted American coordination, but credited training rather than technology. Captured September 1944 intelligence stated American tank units demonstrate good radio discipline and coordination. This appears to result from extensive training and rigid procedures. The technological advantage went unrecognized. German tactics never adapted. They targeted supposed command tanks by antenna count, unaware that every Sherman could coordinate independently. Communication superiority ensured cohesion regardless of visual contact. March 1945, Remagen Bridge. American forces approached the Rhine. The capture of the Ludendorff Bridge demonstrated the speed of American command. The 9th Armored Division reported intact bridges, and within an hour, divisions across the front shifted to exploit opportunities. German forces, reliant on telephone lines destroyed by American aircraft, could not respond comparably. Radio coordination created an impenetrable defense. Tank platoons from different battles